Welcome to this practical session on exploratory data analysis. My idea was to use an existing tutorial and to extend it a bit and to use it to give you a bit more practical experience while working on something bigger that's already leading towards your own project. So I have a motivating example here. Many of you probably also like to watch movies, and what a lot of people do when selecting a movie is reading a review to find out whether they like the movie, whether it's a good movie, whether it's a bad movie. There's a dedicated website that you might know. It's the International Movie Database, IMDb, and you might know them from this ranking of the best movies of all time. But what this website also provides are reviews of movies. And in these reviews, users like you and me just write whether they like the movie or not. So this researcher from Stanford, he collected the reviews and turned them into a binary sentiment classification task. So the data can be used to decide whether a movie is good or bad. Nothing in between. In reality, there's probably a lot in between, but for this particular task, we have highly polar movie reviews that we can use for training, and then we can make predictions about new movie reviews. As I already said, this is going to be based on this blog post by Aaron Koop titled Sentiment Analysis with Python Classifying IMDb Movie Reviews. And he actually did some additional pre-processing for this data set. And as we see here, we have 50,000 reviews. 25 can be used for training and 25 can be used for testing. And of these 25, half is positive and half is negative. So it's a bit like an idealized data set, because in practice you probably don't always have 50-50, but for our use case, it's really, really useful. And what you can read here is that people on IMDb give a rating from 1 to 10. And what they decided to do is they took everything with 4 or less stars as negative and anything with 7 or more stars as positive. So the ones in the middle were removed. That's also already an important modeling decision, but that enabled us here to train a system for this particular classification task. And the first step to follow along is to download the data. And the important part, because there's some additional pre-processing that needs to be done, is to use this link, the merge movie data, and to download it. I already downloaded it, and I can show it to you here. So I put it in a folder called data in the main folder in which I run the IPython notebook. And here we have our train and our test data. So we can have a look here. So this is the first review about a movie called Bromwell High, and that's a cartoon comedy. The way this data set is organized is that the first half are positive reviews and the second half are negative reviews. So yeah, let's get started. As I said, our goal is to identify positive and negative movie reviews. It's based on this tutorial, so please feel free to read this, to go into more detail, to learn at your own pace. And we're going to use this merged movie data provided by Aaron Koop. I'm not going to type this time, so I just ask you to pause the video and then copy what I already did. Is we have two arrays here. We have one array called reviews train and one reviews test. And we're going to load the data. And then again, we have this array and we can look at the different reviews. So this is the 201st review. I think it's a good start in terms of exploratory data analysis to really just play a bit with these and look at different reviews to get a feeling for them. And while doing that, you might notice that we have some problems here. So probably most of you will recognize this as a break in HTML. So in HTML, it creates a new line, but for our machine learning model, it's pretty useless. So we kind of need to have a way to remove this. So the first thing we have to do with our data set is to clean and pre-process it. And here I'm going to show you how to do this using a regular expression. So we define two regular expressions, one called replace no space. So it's replacing all these different characters, and the other one is called replace with space. And that's things that we want to replace by a space, and that's again these HTML marks and these different things in brackets. So we define a function called preprocess reviews, which we give an array called reviews, and then we replace one part without a space and one part with a space. That's this sub, right? Like substitution. And we do that for all the lines in the reviews, and then we return the reviews. So we have the pre-processed reviews and we assign them to arrays called reviews train clean and reviews test clean. We're going to start off with the simple count vectorizer that I already told you about in the natural language processing course. And we're going to use a binary classifier here, right? So we're not counting how often a word is in the review, just whether it exists in the review or not. And we use this scikit-learn function called count vectorizer, and we're fitting this on our train data. And then we're transforming our train data and save that as our x. And we do the same transform for our x test. Let me run that quickly. As you can see, it takes some seconds. And the second thing is that from the article and from the dataset, we know that the first 12,500 reviews are positive and the second 12,500 reviews are negative. So we split our targets accordingly. And this again is just a Python way of writing things. In a way, we have this for loop going from 0 to 25,000. And if the value is lower than 12,500, then we say it's a positive review, we give it a 1, or else we print out the 0. So let's run that again. And here is the train test split that we perform as usual. Again, we take all the data and we try to assign it to an X train, an X test, a Y train, and a Y test. And I have two versions here. This is the one that you probably already know, right? This is just me taking the X, the reviews, and the targets, is positive or not, and then assigning 80% to the training and 20% for the testing. Now, we have 25,000 reviews, so our whole workflow here would take a lot of time if we start with the 25,000 reviews right away. What I recommend you is to start with a small subset. So set the train size to 0.1 and the test size to 0.05. So that means we use 10% for the training and 5% for the testing. And we do this just until we have a model that we can train, a model where we know it works more or less, and then we change this at the end. So we start with just 10% of our data and 5% for the testing. And that's what you can see here, right? We take 2,500 instead of 25,000. And the first thing that we're trying to do here is to train a decision tree classifier that you've already learned about. And we're going to compute the accuracy, the precision, the recall, and we're going to look at the confusion metrics. And these are really the crucial things that I expect in your reports if you do supervised learning. And again, we initialize the decision tree classifier and we fit our model, make our predictions, and then we compute the accuracy by comparing the true values, the Y test, and the Y prediction. And you see that I added a round around this, so I call the round function so that we have nicely rounded values. So in your report, don't have anything more than, let's say, 3 decimal points after the comma, because it's really not that meaningful in this machine learning applications. So we call this, and it's comparatively fast. So what we see here is that our model with the subset of the data and the decision tree has an accuracy of 69%, a precision of 69%, and a recall of 68%. And you can also see the confusion metrics. So again, 0 was a negative review, so there's 435 reviews that were negative, that we correctly predicted as negative, and there's 422 positive reviews that we correctly predicted as positive, and these are the number of false positives and false negatives. So you kind of get a feeling of where we're making mistakes, but as you can see here, we're not really doing them systematically. So our false positives and our false negatives are comparable. We can also train the k-nearest neighbor classifier, and as you can see, it's comparatively worse for the subset of data that we considered, and it's actually making mistakes more systematically here, right? So here, the confusion metric shows that we make a lot more mistakes like this than that. So that's the k-nearest neighbor classifier, and you can copy that, it's working code. Let's try a more sophisticated machine learning model, the support vector classifier. And we're going to use the linear kernel. So we specify the kernel to linear, and as you can see, it takes a bit longer. But we also have a higher accuracy, so our accuracy is 83, the precision is 83, and the recall is 83. That's an improvement on the decision tree as well as the k-nearest neighbors classifier. And again, this is just for a subset, so you already can have a feeling which of the machine learning models would perform best here. And considering this, we can also see that it makes the mistakes in a similar fashion, right? Like we don't have just false positives or just false negatives, and you can see a lot more true negatives and true positives. So based on this, we can conclude that probably for this problem, the support vector classifier is a very, very good starting point. What this enables you is, of course, to play a bit with the parameters. So you might read that the radial basis function in support vector machines is even more powerful than the linear kernel. So let's try this out, just play a bit with it. And this takes quite some time to compute, but interestingly, the performance does not improve. It's actually getting worse. Even though we have quite high recall, our precision is really, really bad. So let's change this back to linear. And it's working again. Data science and machine learning is not just about swapping out models and trying out more sophisticated algorithms. What you can also do is to pre-process your data and to represent your data in different ways that actually yields a strong improvement. And I already showed you the text representation technique called TF-IDF, the term frequency inverse document frequency. And therefore, as a next step, I will show you how this compares to just giving a count vectorizer. So we swap the count vectorizer with the TF-IDF vectorizer, which we initialize, and we fit this on the original vectorizer, and then we again transform our X and our X test. We have to do the split again, and we use only 10% of the data for training and 5% of the data for testing to make this a bit faster. And this is just copy and pasted from the code before. And we're running this again. And we have an accuracy of 87, precision of 86, and a recall of 88. So we can compare this. Yeah, there was a small improvement, right? So 4%, 3%, and 4% again. And you can also see how the confusion metrics improved. There's now a lot of things that you can try out to make this better. For instance, the support vector machine has a hyperparameter called C, and that's determining how close the decision boundary is to your examples. You've seen this already in the lecture. It makes a whole difference of what errors you make and when you make them. Try to fiddle a bit with it to find the right C for your support vector classifier here. So you can also change the type of vectorization we have. For instance, you can set this to false. That means using the actual counts and or using the normalized counts and see how that fares. There's also a second part to this blog article that goes into a bit more detail and actually proposes things like stemming and lemmatization, so that you turn different words into its most basic form, or using n-grams, a technique that we also already saw in the natural language processing class, and the TF-IDF. I already showed you that. So one thing the article also shows you is to remove stop words. And if you look very carefully, you saw that our data is quite large. So we have 2,500 different reviews, and each review has a dimensionality of 92,750. That's the size of the vocabulary. So we have a very, very large space here. So one thing that's really good is reducing this. Removing common words, so-called stop words, is a good starting point, but you could also think about other strategies here on how to reduce the vocabulary size. And if you reduce the vocabulary size, maybe techniques like decision tree, which are very good at being interpretable, we can see the most important words, perform better. I leave you with that, and I think it's a good exercise for you. So the first starting point is, of course, going through this and then swapping these out and training the actual model and to observe how much difference the data make, because here we only had 10% of the data, but you can use it with the entire data, of course, even though it takes some more time. And then reviewing these different points and reading the second part of the blog post. And there, Aaron actually shows you how to remove the stop words, how to do a bit more feature engineering. And I hope this is a good starting point. And it's also nice for you now to reflect on what we did here. So with the code that I showed you and that you hopefully understood by now, we trained a system that takes an arbitrary review and gives us an indication of whether the review is positive or negative. Now, there's a lot more to understanding language, but I think it's pretty cool that we built such a sophisticated model as a starting point in such a short time. And I hope this is an inspiration for you. You could extend this, for instance, into a spam filter, but you could also extend it to other information filters that, for instance, help you sort your email in a clever way, and that, for instance, help you to find the most interesting content on Reddit. So go crazy, have fun with it. Hopefully this inspires you to do a very nice final project in this course.